Welcome to part 2 of 2.5 squared. In the first part, we established arithmetically and geometrically that 2.5 times 2.5 is 6.25. At this time, we want to take advantage of the fact that 2.5 is a fraction whose decimal equivalent terminates. And of course, it's simply 2.5. So the same problem of 2.5 squared can be thought of as 2.5 squared, or 2.5 times 2.5. And at this point, we want to make the observation for fifth graders that one of the challenges is to understand the difference between the algorithms for adding and subtracting decimals on the one hand and multiplying them on the other. The algorithms are completely different. Of course, with addition and subtraction, we line the decimal points up so that when you add or subtract the digits, you're adding and subtracting digits in the same place. It doesn't make any sense to try to add tenths to hundredths or to subtract tenths from ones. So that lining up of the decimal point causes all of the digits to be in the correct place. We add or subtract as usual and then bring the decimal point straight down into the answer. But multiplication is a different approach. We start by pretending that we're multiplying two whole numbers. When we write it vertically like this, 2.5 times 2.5, we're not going to bring the decimal points down. A lot of students want to do that because they've already learned that approach from addition and subtraction. But we'll ignore the decimal points, pretend that we're multiplying two whole numbers, 25 times 25. "25 times 25 is 625. That's obviously not the answer to 2.5 times 2.5. So the multiplication algorithm tells us to look at the two numbers we're multiplying and count how many digits in total there are to the right of a decimal point. There's one there and one there. A combined total of 2 digits to the right of the decimal point. So our product has to have 2 digits to the right of the decimal point. We insert it like that. Give me a little more space here. And we get an answer of 6.25. 6.25, of course, is the same as the 6.25 that we got by multiplying with improper fractions, and the same answer that we got geometrically by looking at the big square. So one of the reasons that I like this lesson so much is at this point we can talk about why the decimal algorithm works the way that it does. And one of the messages that I constantly try to get across to my students is that decimals are simply fractions. They're another way of writing special kinds of fractions that have powers of 10 in the denominator. So that 2.5 times 2.5 is really fraction multiplication. It's 25 tenths times 25 tenths. 2.5 is 25 tenths because we have one digit to the right of the decimal point. So we need 1 0 in the denominator following the 1. The numerator is simply the 2 and the 5 without the decimal point. It's the whole number 25 over the 10. And multiplying across the top and bottom, as we do with fractions, we get 625 over 100. And this is the product. This is the answer to 2.5 times 2.5. But to convert that back now to a decimal, and this is something that happens a lot in middle school, whether we're talking about decimals, decimal multiplication, or improper fraction multiplication, we frequently want to switch back to another form. And 625 over 100, we see in the denominator 2 zeros. So to write this as a decimal number, we take the digits that are in the numerator, 625, and write them in such a way that we have 2 digits to the right of the decimal point. corresponding with the 2 zeros. And there we're back to the 6.25. So we'll call this the end of part 2 of 2.5 times 2.5, where we looked at the decimal multiplication algorithm. And so long for now. See you soon.